So we are focusing on the high frequency behavior of your BJT, and we have seen yesterday in the last class what is the different regions in the frequency response. We have low frequency region, we have mid frequency region, when we have high frequency region, and it is in the high frequency region we concentrate more, because in that region we have all those capacitances dominating, and they will try to pull down your gain of your amplifier. And as I told you, the capacitive reactance at high frequencies will be very less. So it will more or like your capacitance will short circuit everything to ground. So that is the reason why your gain is going to drop. So to further understand to further study the effects of high frequency capacitances, we are going to choose the hybrid pi model. And we have seen two models for transistor: H parameter model and hybrid pi model, right? H parameter is used for low frequency analysis, and hybrid pi model is specifically designed for high frequency analysis because it considers all the capacitances which are involved in the fabrication of your device. This model should be thorough to you. You should study this in your devices. So what we see is emitter, base, and collector, but actually when they fabricate your BJT, you have one more terminal called B dash, which is called as your virtual base. So between B and B dash, you will be having a resistance RB B dash. And see, between all these B dash, C, and emitter, you will have a pair of resistance and capacitance. So between B dash and E, you see, you have RB dash E, you have RB dash E and CB dash E in parallel. Between B dash and collector, you see CB dash C and RB dash C in parallel. Between collector and emitter, you see RCE. You will have one more capacitance CCE, which is not very predominant, so I am omitting that. Otherwise, you will be having three pair of RC combination between the three. This is how you should remember the diagram. You should not mug up anything. This resistance is between the two bases R, B, B dash will come. Other than that, between B dash and emitter, you will have a pair of RC combination. Between B dash and collector, you have a pair of RC combination. Between collector and emitter, you have a pair of RC combination, but the capacitance effect is not very predominant, so I am going to remove that capacitance. And you will have the current source GMVB-E. So in high frequency, you will be having the current source, which is going to have the trans conductance GM. Okay, so at high frequency, the capacitance effects of the transistor junctions are going to be modifying the response of your transistor. So you have three capacitance between the terminals B dash E, B dash E, C, B dash C, and CCE. So these capacitance are going to affect the high frequency response of the transistor. So what they will cause? They will cause some delay in the response. So they will cause some unwanted delay in the response. The gain will get reduced, the bandwidth will get reduced. So all these will happen at high frequencies. Okay. So for this reason only, for analyzing the high frequency response, we are going to take a hybrid pi model, or it is also called as Giacoletto model. Giacoletto model, as it is shown in the figure. So this is the simplified hybrid pi model for a common emitter BJT. Okay, we are going to consider this hybrid pi model for our further analysis. Okay, I hope how to draw the diagram is very clear. So you should not mug up anything. First, mark the terminals B, B dash, C, and E. Emitter is grounded because we are going to take common emitter configuration. First, draw resistance between B and B dash, base and the virtual base. Then between every terminals, you draw pair of R and C. After drawing the R and C in the collector emitter junction, you remove that capacitor. Then you have the current source, add the current source GM into VB dash E. If you are connecting any resistance externally, that will come somewhere here. So that will be your RL. But since your hybrid pi model does not include the externally connected components, it is left as open at the output side. Okay, I think this diagram is very